Welcome back, Year 5. In today's math lesson, we're going to continue working on dividing decimal numbers. But instead of just doing it by 10, today we're also going to be dividing by 100 and 1,000. Once you've mastered the trick of multiplying decimals by these numbers, it's really easy to do the division because it's just the opposite. So our learning intention today is to use our understanding of place value and division of decimals by 10 to develop fluency in dividing decimal numbers by 10, 100, and 1,000. All right, Year 5. So as you can see today, I'm still using this setup. I haven't had any major complaints about it, but what I did notice when I watched it back is that sometimes I write kind of too small. So today I'm only going to be putting one problem up on the board at a time and then wiping it away. So please follow along in your notebooks as I go through this. Pause the video whenever you need to so that you can catch up. All right, so we're starting by looking at just some examples of dividing by 10, 100, and 1,000. It's really not that difficult once you understand how to multiply by these numbers. Remember when I used that sliding chart and we could just move the numbers around? Well, it's the exact same concept, except we're making the numbers smaller, either 10 times smaller, 100 times smaller, or 1,000 times smaller. So what I'm going to show you today is how to use the decimal point trick, because when you don't have one of those sliding boards, the decimal point trick is the easiest way to do it. So let's start with question A. 456.3 divided by 10. All right, now since I'm dividing by 10, everything is going to move one place because I have one placeholder in the number 10. Remember, since I'm dividing, the number is going to become smaller, specifically 10 times smaller. That means my decimal point is going to move in such a way that my number becomes smaller. So my decimal point must move forward. That way, the numbers appear to be moving backwards. So my decimal point will now appear in between the 5 and the 6. So my answer is going to be 45.63. My answer is smaller than what I started with. And that makes sense because I am dividing. So again, since I'm dividing by 10, all the digits move one place, or I can move that decimal point one place. Let's try the next question now. It's the same number except we're dividing by 100 instead. So I'm going to wipe this clean. You get rid of all my working out, but I'm going to keep that number. And now let's divide by 100. So what's the difference when I'm dividing by 100? Well, the number 100 has two placeholders, two zeros. So that means everything is going to shift two places instead. So I'm going to move my decimal point two places to make it appear that my numbers have moved backwards. 1, 2. My decimal point is now going to appear in between the 4 and the 5. So my new number, or my answer, will read 4.563. And again, I know it makes sense because it's smaller than my starting point, and when we divide, our answer, or the quotient, is always smaller. And if I work it backwards, I can multiply this by 100 and I'll see that I get back to my starting number. Finally, let's divide the same number by 1,000 for question C. So you're probably like, Miss Osborne, we get it, we know how to do it. Well, I'm going to explain it one more time just in case. Since I'm dividing by 1,000, I check how many placeholders I have, and I have 3. That means everything needs to move 3 places. And my number is getting smaller because I'm dividing. That means my decimal point is going to move forward. That way the numbers are shifting back towards the right. So I need to move 3 places. 1, 2, 3. My decimal point now is going to appear in front of the 4. I always like to start my answers with the ones place, so I'm going to put a 0 in the ones place, then put down my decimal point. And then I write everything that would come after. 4, 5, 6, 3. My answer, 0.4563. If you leave off the 0, your answer is still correct. You just have to include the decimal point. Personally, I just like to put that 0 there. So there we have it. When you when you divide by 10, 100, or 1,000, your answers are getting smaller. And to do that, you move the numbers towards the right. Or you can move the decimal point in the other direction to the left so that it appears that the numbers have moved down. Let's move on to question D, which is a little bit different. It says there 389.72 divided by something gives an answer of 3.8972. Well, oops, sorry, it's shaking. For this problem, I'm trying to work out whether it's 10, 100, or 1,000 that this number has been divided by to give this answer. The easiest way to do these is to just check with the decimal point trick. So my decimal point went from appearing here to appearing right after the 3. So it's moving from here to here. How many spaces did it jump? Well, let me just check. 1, 2. That means my answer must have 2 placeholders. So my answer is going to be 100. When I divide this number by 100, I get 3.8972. And I could check it backwards as well. I could say, well, what do I need to multiply this by in order to get here? Well, if I multiply it by 100, the decimal point then appears after the 9 like it does over here. Let's try E, which is the same type of problem. $76.45 divided by something gives 7.645. All right, well, all I'm doing is checking how many places the numbers or the decimal point have moved. So it went from appearing behind the 6 to now appearing in front of the 6. So let me just see how many times it jumped. It jumped only once. If it jumped only once, that means that my number has only one placeholder. So my answer is 10 because that has one placeholder. Now let's move on to F and G. These are similar to D and E, except we know what we've divided by. We just don't know the starting number. So for F, some number divided by 100 gave the answer 0.3267. Well, for this one, I know where I land, and I had to divide by 100 to get there. So if I do the opposite, I can work my way back to the start. What's the opposite of division? Multiplication. So let me multiply this by 100 to see what the starting point was. So I'm going to make this 100 times greater by moving 2 places. 1, 2. My decimal point should appear after the 2 and before the 6. 32.67. How do I know if this is right? Well, let me just try it going the other way now. If I divide this by 100, it's going to get smaller, so my decimal point moves the other way, and it will move 2 places the other way. 1, 2. The decimal point will then be in front of the 3, and that's exactly what I see over here. So I know this answer is correct. 32.67 divided by 100 will give 0.3267. Finally, G. Some number divided by 1,000 is going to give 4.719 as the answer. Again, I don't know where I started, but I know where I end and how I ended up getting there. So if I do the opposite, by working backwards, I can find my starting point. So instead of dividing by 1,000, I can take this number and multiply it by 1,000 to see what my starting point was. So let's multiply this by 1,000. 1,000 has 3 placeholders, so I need to move 3 times. 1, 2, 3. My decimal point should be after the 9. So my answer, 4,719. Point nothing, so I don't need to put the decimal point in this case because there's nothing coming after it. But I know now if I want to check it backwards, or forward I guess, if I divide this by 1,000, the decimal point would go from here 1, 2, 3 places and end up between the 4 and the 7, which is exactly what I see over here, so I know I'm correct. Alright, so now for the discover portion. There we see a 3-part picture. In part 1, there's a woman in the kitchen and it looks like she's cooking with some curry powder. She has a small sachet of curry powder. In the second picture, we see the inside of a supermarket, and on the shelf there are some cartons of curry powder, and it says that there are 10 sachets per carton. So I can imagine that inside of each of those cartons, like those small boxes, there's 10 sachets. So how many sachets are on the shelf right now? Well, I could just count in tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Because there's 10 boxes and each box has 10. In the third picture, it says that in that large box, it contains 10 cartons, just like we saw on the shelf a second ago. Each carton contains 10 sachets. So what I'm noticing is that in the third picture where we see that large box, it seems that they've just taken the contents of that large box and put it straight onto the shelf from the second picture. Alright, with all that information in mind, let's start 1A. It says there, how many sachets of curry powder are in the large box? Well, that's easy. We kind of worked it out already. Because notice, there's 10 cartons inside the box. 2, 3, 4, 5, 6, 7, 8, 9, 10. So it tells me that there's 10 small cartons inside the box. And I know each of these cartons contains 10 sachets. So if it wants to know how many sachets there are in the large box, all I have to do is count 10 times. So all I'm doing is solving 10 times 10. And that equals 100. So interestingly enough, that first problem was not a division problem, it was a multiplication problem. I suspect that the B part is going to ask me to do something with this information. So I know that there's 100 sachets in the large box. Oops, I always spell sachets wrong. S-A-C-H-E-T-S. There we go. Take a moment, make sure you have your notes down because I'm going to move on to this B part. Alright, so let me wipe this clean. And I have in my mind that there are 100 sachets in that box. For the B part, it says the total mass of the curry powder in the large box is 8.5 kilograms. How many kilograms of curry powder is in each sachet? So here's my big box, and it weighs 8.5 kilograms. But inside this big box, how many small sachets are there? 100. So if I want to find out how much just one of those little sachets weighs, I have to take this weight and split it up amongst 100 packets. When I say split, I mean divide. So I'm going to end up doing 8.5 kilograms divided amongst the 100 sachets. Oops. And that will tell me how much just one sachet weighs. Well, I'm dividing by 100. I notice 100 has 2 placeholders. So that means everything is going to shift 2 places. I'm making my number smaller because I'm dividing. So my decimal point is going to move this way. 1 place, 2 places. So my decimal point ends up over here. Notice there's a space before the 8. What goes in that space? A placeholder. So my answer is going to be 0. Here's my decimal point, 0.085 kilograms. Each sachet weighs 0.085 kilograms. Alright, that's the discover portion. It had us use our skills of multiplying by 10, 100, 1,000, as well as our skills of dividing by 10, 100, and 1,000 to solve those problems. Let's move on to the think together portion. Now for the think together. It says there for question 1, divide each of these numbers or amounts by 100. I'm going to do the first two on my board, and then you're going to do the second set of two on your own. For the first one, it says 12.8 kilograms divided by 100. Again, I have two placeholders, and since I'm dividing, my answer is going to be smaller than my starting point. So my decimal point is going to move that way. How many places? Twice. 1, 2. My decimal point should now appear in front of the 1. So my answer is going to be 0.128 kilograms. I have to put back kilograms because my starting number was a measurement in kilograms, so my answer when I divide it is still going to be in kilograms. For the second one, again, we're dividing by 100 like it said. I've got my two placeholders. This time I'm dividing 2.52 meters by 100. Still, I'm going to move two places. 1, 2. So my decimal point is now going to end up here. Notice though that on my second jump, there was nothing above it. There has to be something above it now because we've skipped this place. So what goes in an empty place? A placeholder. So my answer is now going to be 0. Here's my decimal point, 0.252 meters. Got to put back my meters because I started in meters. You're going to solve the other two problems, 128 divided by 100 and 0.9 divided by 100. Keep in mind, as they get smaller, sometimes there's going to be a space left open by your jumps. You have to fill those empty spaces with a placeholder. If I just put my answer as 0.252, that would not be correct. I would have only divided by 10 because I would have only moved the decimal point from here to here. That's only one jump. So make sure that you put your placeholders in. If you haven't done so yet, make sure you pause the video so that you could work out those two problems from question 1. I'm moving on to question 2. It says, the milk is used in a recipe for 100 scones. I see a picture of the milk off to the side and it's a 4-liter bottle. Okay. How much milk is in each scone? So that means I'm taking, for this problem, question 2, the 4 liters of milk, 4L, and splitting it up amongst how many scones? 100. Remember, whenever you split something up, you're dividing. So I'm dividing 4. I'm going to take away this the liters for now because sometimes it gets confusing and you might think it's a 1. So I'll make sure I put it back at the end. So I'm taking those 4 liters and splitting it up into 100 different groups because there's going to be 100 scones. That will tell me how much milk goes into each scone. Right now, the decimal point in 4 is right behind the 4 because this is my ones place. Since I'm dividing by 100, I need to jump 2 places. And I'm making my number smaller because I'm dividing, so I have to move my decimal point forward. 1, 2. My decimal point will now appear here. But notice on my second jump, there was nothing above it. So what do I have to put there? A placeholder. Otherwise, my answer won't be correct. So when I take 4 liters and split it up amongst 100 scones, I end up with 0.04 liters. I can check that going backwards. If I multiply this by 100, I should get 4 liters. And sure enough, look, 1, 2. My decimal point ends up behind the 4, just like it was at the beginning. So make sure you have the placeholder in. All right, now we're ready for question 3. Question 3 I want you to do on your own because you've seen me model a lot of these. But in the book it just says divide each of these numbers or amounts by 1,000. What I want you to actually do in your notebook is write the amount and the whole number sentence. So 12 is the first one for A. Let me put my A in. 12 divided by 1,000. And you'll put your answer at the end, of course, and I should probably see you doing some jumps or something along those lines for you to get your answer. Do the same for the rest of them as well. B is 6.2 divided by 1,000. C 718 kilometers. So remember, your answer should end in kilometers as well. Divided by 1,000. And finally, for D, 0.7 divided by 1,000. So you'll copy these into your book and solve them. All right, Year 5, I'm mindful of how long the video is getting, so it's time for you to start your independent work. Today it's taken from pages 48, 49, and 50. On page 48 for question 1, you can use those place value grids to help you solve the problems. If you prefer just to use the decimal point trick, that's fine too. For question 2, Bella says that dividing by 10 and then 10 again is the same as dividing by 100. This is true, because when you divide by 10 and then divide by 10 again, you've moved your number 2 places over. That's the same as when you divide by 100, because 100 has 2 zeros, 2 placeholders, so you move 2 places. To show that in that little grid off to the side, we see that's already been split into 10. So you have to split it in 10 horizontally, and then you'll end up seeing that the whole grid has been split into 100 because you've split it into 10 and then split it in 10 again, so you've divided it by 100. Underneath, you'll just explain that. Question 3 just has you determine whether or not each statement is true or false. Please look at those carefully. For number 4, you're going to draw lines to match the calculations that give the same answer. Not all of them have a pair. You're going to need to work out each calculation and find the answer before you match them up. At the bottom, you simply need to complete the calculations. So you'll need to determine either what you're dividing by or what number is being divided to get to the given answer. On page 50, question 6 is quite challenging. It says, each day Zach and Jamie put some money in their money box. After 100 days, Zach has 18 pounds and Jamie has 124 pounds. If they always put in the same amount each day, how much more money did Jamie save each day in pounds? This is a multi-step question because what you have to do is work out how much money Zach put in each day by dividing by 100, and then you'll work out how much money Jamie put in each day by dividing by 100. Then you need to calculate the difference in the amount they put in each day. That will tell you how much more Jamie saved each day than Zach. And the challenge today is quite tricky as well. It says each shape represents a different number. Find the missing values. So a square divided by 10 is equal to a triangle times 100, which is also equal to 0.098. Now, break this down. You can split these into 2 separate number sentences. First, you can have a square divided by 10 equals 0.098. Also, you can have a triangle times 100 equals 0.098 because both number sentences equal 0.098, so they have the same answer at the end. So break it into 2 number sentences and then work backwards to find what the shape is. It's the same with the other side. A star times 10 equals 0.61 divided by 100, which equals a circle. Your number sentence in the middle, 0.61 divided by 100, is going to tell you what a circle is. And then when you figure out what that is, you can say, okay, a star times 10 is going to equal the same thing as the circle. It is tricky. Take your time, work it out. And as always, make sure you do the reflection at the end. All right, Year 5, that's all for now. Stay safe and I'll see you soon.